We did one full equivalence relation proof and found two distinct equivalence classes. So we're going to keep doing that now. Reminder, an equivalence relation is a relation that is reflexive, symmetric, and transitive. Equivalence classes, they're the set of elements that are equivalent to, that are related to the element you're talking about under this particular relation. So let's do another one if we feel good about it. We have this relation E, where A is related to B, or A, E, B, if and only if A minus B is even. So I do think that we should do some scratch work here. You're welcome, Janaya. So let's sort of break this up and do. Oh, what? Oh, should I do that? Do I always do my scratch work sideways?
Yeah.
Mm-hmm. Sorry, Sharon. You can keep it that way. Okay, so we want to show that it is reflexive, symmetric, and transitive. We start with reflexive. How do you know if it's reflexive? Yep. So we're going to let X be in Z, and we want to know is X. Oh, I don't care. A is A, E, A. So in this one is A minus A even. Yes or no? Yes, because it's 0. So this is reflexive. Talk to me about symmetry.
A relates B, then B relates A.
Yeah, so we're going to let A and B be integers and assume A is related to B. We want to show that B is related to A. Oh, shoot. This is an E, not an R. I always do this. But it does not really, you can change it at the beginning to an R. You know, who's going to judge you? No one. Oh boy, I'm judging myself, but it's fine. Okay, so if I know that A is related to B under this relation, what does that mean? On this one, that A minus B is even, right? That's what I do know. What I'm trying to show is that B minus A is even, yeah. Trying to show B minus A is even. What I do know, though, is that A minus B is even. So that means that A minus B is 2K for some integer K. What does that tell us?
K equals A minus B over 2.
Yes, but not helpful.
B minus A is 2 negative K.
Are you thinking about that?
That's still just even, it's just a negative even number, so it doesn't matter how it does negative.
right? Like 4 minus 2 and 2 minus 4. They're both 2. One's positive, one's negative. Yeah. So yeah, this is still even. So B minus A is even. So B is related to A. Oh, darn it. That's an E. Because it was in the problem, Janaya. I don't know.
Oh, okay.
But like, if I really wanted to, I could just do this and be fine. Because it's evenness. That's why it's an E. Okay. Transitive property. How do we do transitive property? Corey, do you not have notes?
I do not at the moment. I mean, it's not a huge deal. I can just,
It is. It's a huge deal to me.
you know, we kind of spent most of our academic careers writing on just plain paper.
I can't give you my notes, even though they're blank after this one, but I want this proof.
Okay. I guess I'm good.
Okay. Okay. Transitive property. I don't know. Remember what I'm doing. A, B, C, and Z. What do we know? A, E, B, and B, E, C. What do we want to show? Good. Okay, what do I know? Can I write this as 2K and 2L? Alrighty. What am I trying to show? That A minus C is even? Okay, so how do I get A minus C?
A, yeah.
Adam, that's right. If I do A minus B plus B minus C, I have 2K plus 2L. This is A minus C is 2 times K plus L. K plus L is in Z, so A minus C is even. All right, how are we doing? Okay? Hey, that's very small. Okay. Proof. Define a relation E. Oh, sorry. Sorry, no, I don't like it. I don't like it. Mm-mm. I'm just going to write that sentence again. For A, B, and Z, define A, E, B, if and only if A minus B is even. We will show E is an equivalence relation. First consider A minus A, which is 0. Since 0 is even, A, E, A, and E is reflexive. Ooh. Now assume A, E, B, thus A minus B is even. We have A minus B equals 2K for some K in Z. Notice B minus A is 2 times negative K. Since negative K is in Z, B minus A is even. Thus, B is related to A, and E is symmetric. Oh, it's quite an underline. How are we doing with those two so far? Fine? Any questions or comments? I'm hungry. It's not good. No, I gotta teach till 1:20. It'll be fine. I'll make it. They'll do other people good. They won't do me any good. The people who have to deal with me being hangry will appreciate it. Okay. Now, no, don't say now. I already did that. Y'all notice that most of my struggle is words. That's why I chose to do math, I think.
Next.
Huh?
Next.
Next. They didn't tell me English would have in this class.
Oh, yeah, lots of it. Next, assume AEB and BEC for C and Z. Then A minus B is 2K and B minus C is 2L for some K and L in Z. Corey, you say, like, we've been taking notes most of our academic careers. You know that most people who, like, sit in a classroom, if I don't hand them notes, they just wouldn't take notes. They would just sit there.
Is that so?
Yes. That's why I hand people notes.
Luckily, we're a pretty good class.
You are a great class. Y'all are a wonderful class. Discrete is usually my least favorite class. Not this semester. Yes, Emily.
Did you have to say A, B, C, and Z?
Yeah, I kind of hate that I've done this, and I apologize to you all, but I called this out first. I said A and B were in Z. So if you don't like, if you want to say it again, go for it, I don't like that I haven't said it again. I would almost always start them by saying, let A, B, and C be in Z. Yeah. Since I've already called them in integers, I'm just leaving it, but yeah. I like the question. Okay, then, so next, obviously, clearly, look, observe. Notice A minus B plus B minus C is equal to 2K plus 2L. This is A minus C is equal to 2 times K plus L. Since K plus L is an integer, A minus C is even. Thus, A is related to C and this relation E is transitive. we have shown E is reflexive. Oof, my hand already hurts, which is bad news. Symmetric, which means the handwriting is getting worse too. Sorry, I'll work on it. And transitive. And thus, E is an, whoa, Dr. Probin. He's yelling and beating on the board. It's like Dwight giving a speech. I can't beat on the podium because my mic on my thing is going to blow out Eunice's eardrums. You know Dwight giving a speech from the office? Michael does. Emily, do you know this? He stands up and he's like, I can't do it. If I did, it would probably make it like, yes, I know. But Johnny, have you ever watched The Office? Oh, you should. You should. It's good.
They took it off of, I think it was Netflix or something.
Yeah, because they put it on Peacock.
Yeah, it's so stupid. I got like 6 seasons in, I couldn't even finish it.
That's annoying. Peacock's really cheap though with the student thing. It's like $24 for the year or something.
I used the student discount for Spotify.
They get Hulu too,
Yeah.
for $5.99 a month.
Yep.
Nice. We do Disney Plus, Hulu, ESPN combo thing, but that's gotten more expensive. So
I hate how everything's like.
its own thing, and you got to pay for all of them. Me too.
You have to pay for an initial account, and then now everything's like, well, pay if you want to watch this specific thing we have.
Yeah.
What?
Yeah.
Like Disney Plus Premium. Like, can I just watch this without commercials, without paying more? Like, I don't understand. No, it is crazy. We need to do equivalence relations on this one. I mean, equivalence classes. That's what I meant. So, like, pick your favorite number, integer number. 6. So the equivalence class of 6, what does that mean? This is the part that really gets students most of the time. What does it mean to be in the equivalence class of 6?
It's the only thing where the relation is true.
Yeah, it's all the elements that are true with that number, right? So it's going to be the set of all x in z such that 6 minus x is even. So what are things in there that would make that true? Yeah, this is just all the evens. Even minus an even is an even. Okay, so give me your next favorite number. Somebody said 2.
Yep.
Okay, Michael, can I use 2 now to find a different equivalence class? No, because 2 is in this one. So the equivalence class of 2 is going to be the same as the equivalence class of 6. Yeah? So what's not been included in an equivalence class yet? Great. 71. So this is going to be the set of all integers where 71 minus x is even. And what are things that are going to make that true? All of the odd numbers, yeah. Good. Yes? So you pick an element, you figure out some things that are related to it. If it seems like it's going to be a whole bunch of things, it might be. It could not be. Okay. Well, these ones ask, and I think because the directions on this says, like, if it's an equivalence relation, prove it. The ones on your homework will say, I'll try to put them on there.
yeah, he said like for 9 and 10, he said,
Yeah.
"Really following and find two distinct.
Yeah. The other ones, like some of them you're doing scratch work to show that they are equivalence relations. Some of them you're doing finding a counterexample to show why it's not. And some you're finding equivalence classes. So yeah. Some of them the equivalence classes were weird. So okay. Any questions about this relation E being an equivalence relation? No? Oh, great. Let's keep going. So M and N and S and T are in the rational numbers. What does that mean about M, N, S, and T? That they're integers, yes. And what about N and T?
That's not the exclusion sign. That's the other way.
Right, yes. Yep. This is division.
Okay.
These are fractions. They're like, oh, sorry. These are fractions. Yeah, the N and T are not zero. Good. So M, N, S, and T, all integers. N and S are, oh no, N and T are not zero because these numbers are in the rationals. So, I mean, if you think about this, y'all, this is saying that M over N is equal to S over T if and only if MT is equal to NS, which is facts. Yeah? So we're showing that this is an equivalence relation, that reducing fractions makes them still be the same. Yeah?
Yeah.
Okay. So, scratch work, I guess? Or do you want to jump in?
You know my answer.
Yeah, I do. Okay, I'll do some scratch work. For reflexive, I'm going to let M over N be in Q. I want to show what? For reflexivity, what do I want M over N to be looking at? Itself, right? So we want M over N to be related to M over N. And what does that mean under this relation?
M over N is equal to M over M, and Mn is equal to Mn.
NM, I think, but yes. Yes. Yeah. And is that true? Yeah. Yes, M and N are integers, so M times N is the same as N times M. So M over N is related to N over M. No, 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 no. M over N again, sorry, my bad. Can I change something? Can I make this be an R so I don't have to write a squiggly a bunch of times? Okay, because when you say like, thus R is reflexive, I don't want to say thus squiggly thing is reflexive. Yeah? Okay. Alrighty then. We have reflexive done. How about symmetric? I want to let M, N, and ST be in Q. I want to assume that M over N is related to S over T. That means that MT is equal to N times S under this relation. What do I want to show?
ST related to M.
Yeah, the ST is related to M over N. And what does that actually mean?
S times N equals M times T.
T times M. Yep. It's very aggressive. Corey, you haven't had Dr. Proven yet, huh? The rest of you have or have not?
I have not.
What does he teach?
I have.
You have. He teaches all through the calculus sequence. This is differential equations he's teaching right now. Cosmology, pre-cal,
Yeah, I had Martinez for calculi.
all of them.
Well, I had Reed for calc one, but and then I have not been able to do differential equations yet. It's
Okay.
always at the same time.
Yeah.
Who teaches data structure?
A's. Data structure analysis. I mean, A's.
Have heard bad things about that class.
I've heard it's hard.
He recommends if you miss an assignment, don't try to make it up. He'll take it, but you just have to keep going on the assignments or else you'll get really backlogged.
So I'm like,
I have heard, yes, horrible things about that class.
But if you go to office hours, it helps. Like most of them.
Dr. Hayes is so nice too.
He's awesome.
Or was one of you the people he told yesterday that maybe taking notes would be a good idea? See. Yesterday, Dr. Hayes told, or Tuesday, Dr. Hayes told somebody out at the table, I don't know who it was, it might help if you took notes in class.
I think I know who that is.
Do you?
It's not something.
That's good. Because I'm sure Dr. Hayes was nice, and I would be like, what is wrong with you? What are you doing?
Someone I keep hearing about who was watching YouTube videos in class.
Yikes.
He's on his second attempt for some reason.
Shocking. Janaya, was Giggles in your pre-calculus class with me?
Who is Giggles?
No? Okay.
No.
There is a student who I had in pre-cal. You were not with Emma and Robin? There was a student I had in pre-cal who would sit on his phone in the back of the classroom and watch videos, but he would laugh out loud at the videos on his phone. And every time he did it, I would just stare at him.
That wasn't
He
the last
never looked
question.
up. He never saw me. Everybody in the class would giggle at me, staring at him. No, but he had no idea.
We should have asked him to present the video to the
Yeah.
class.
Kid asked me a question on Tuesday, and I answered it, and I said he doesn't understand, because somebody was trying to answer it for me to him. I said he doesn't understand because he wasn't listening. He was on his phone when I was teaching this. And the kid was like, I was listening, like. I'm the one doing this job, staring at you, staring at your phone. Like, I don't know what you think. You may be listening, but you weren't, like, paying attention.
That's why I say hearing and listening.
Correct. I tell my children that all the time. You hear me, but you are not listening. Like, there is a difference. But I got really, really snarky. Like, I don't want to answer your question because you weren't listening. This is taking everybody's time because you chose not to. So, sort of like I'm doing right now. It's still affecting me. Okay. How does this work? I mean, we're done, right? This is multiplication with integers, so Tm is equal to Sn, and then the equal sign, is an equivalence relation. Shocking that. So Sn is equal to Tm. So S over T is related to N over M. No, dang it. Darn it. Over N, yeah. Killing it. What's wrong?
It just seems like a lot of work just for you to like switch sides.
I know, right?
Where the thing were.
I know. It sure does. Like, I already know this answer. Can I just write it down? I'm going to do this proof with these two properties, and then I'll do the scratch work for transitive. Is that okay? Because I want to be able to see these while we do the thing. Okay, so define, gosh, I gotta think through my words here. I don't want to do the same thing where I let M and N and S and T be in Q and then don't call them again. I don't like that. But maybe I just do that anyway. Okay, for M over N and S over T in Q, define M over N is related to S over T if and only if MT is equal to N times S. We will prove R is an equivalence relation. I'm just doing it, let M over N be in Q. Notice M and N are in C, so M times N is equal to N times M. Thus, M over N is related to M over N, and R is reflexive.
I see what you mean now. I'm not saying and squiggle is reflection.
Yeah, squiggle and squiggle and squiggle. No. I hate that. And when students turn it in, I'm like, ugh, ugh, ugh. Okay. Now, oh, I should put this on a new line. Reflexive. Now, let M over N, S over T be in Q. I'm really struggling with that Blackboard bolded Q. And assume M over N is related to S over T. Then M times T is equal to N times S. Hi, Eunice. Did you bring me cookies or something? Oh, bummer. That looks like a box from a bakery, right? Or am I just that hungry? Darn. Maybe it's a package from a bakery.
Maybe cardboard, is that all? Who knows?
It doesn't look like it's from Romania because it looks like it's in very good shape. We love Amazon. Also hate Amazon. So both. How do I want to say this? Again, since M, T, N, and S are integers. Uh-oh. We have Tm equals Sn and Sn equals Tm. Thus, S over T. This is the wonkiest proof for you to walk in the middle of, Eunice. S over T is related to M over N. And R is symmetric.
You're not still doing squiggle.
Yeah, true, true, true. Now she's settled. She can do the transitive property. How are we going to prove that this thing is transitive? Carefully. We're going to let S, darn it, okay. Deep breath, M over N. S over T, I'm going to use Q and R, be rationals. Okay. We're going to assume M over N is M over N is related to S over T, and S over T is related to Q over R. What do we want to show?
Mn relates to Q.
So what we have then is that MR is equal to N times Q. That's what we're chasing. Okay. What do we have from our assumptions? No, MT, cross multiplying, MT equals NS. And what else?
TQ equals SR.
TQ equals SR. Or SR equals TQ, yeah. Okay, so we're going to use substitution. But we have to be careful about this. We can only divide by one of these guys because those are the ones that we know aren't 0. So we can divide by N, we can divide by T, or we can divide by R. We're trying to get MR is equal to N times Q.
Or
What if I divide this one by N? That gives me an S, which I can plug into here. Okay. So if I divide this by N, I have M times T over N is equal to S. And T times Q is equal to M times T over N. Oh my gosh, times R. That's so very small. Scooch that over. Okay. So I'm going to multiply that N to the other side. So I have TQN. Am I tracing the right thing? Oh, there's the TQ I wanted. That's good. And M. Uh-oh. MTR, which is not all that helpful.
So you can divide by T now.
Oh, yes, and I have NQ and MR just on the wrong sides of that equation. Thank you. I can divide by T because it is another one that's not 0. Good, good. Thank you, Janaya. So I have QN is equal to MR, or NQ is MR. So M over N is related to Q over R. Yeah? What about it? Why did I?
Yeah.
To make it go, because the way that it's defined is bottom to top. But we already proved that that was okay. Oh, Lordy. I don't know how necessary that is, but to make it fit the definition. Okay, you want to write this part up now? I don't really. The next one, we're just doing scratch work. I'm tired. All right, now let M over N, S over T, Q over R be in big Q. Then M, S, Q are integers, and N, T, R are integers that are not zero. There's the toss thing you were talking about earlier, Michael. We are going to assume M over N is related to S over T, and that S over T is related to Q over R. Then MT is equal to NS, and SR is equal to TQ. We have S is equal to MT over N. So MT over N times R is equal to T times Q. MTR is equal to NTQ. Yeah, I'm trying to figure out why the order is different than when I did this a minute ago. What did I do before?
You had TQ on the left side.
Oh, well, yeah, that really messed me up, huh? I had to do more work to make it fixed. Whatever, it's fine. MR is equal to N times Q. Thus, M over N is related to Q over R, and R is transitive. Since R is reflexive, symmetric, and transitive, it is an equivalence relation. Okay. We need to find equivalence classes under this equivalence relation. So pick your favorite rational number, somebody. Eunice, what's your favorite rational number? 2/3. 1/2. 1/2. Okay. So wow, that square bracket was not so square. Okay, well, apparently I can't draw a square bracket. It's fine. The equivalence class of 1/2 is going to be everything that is equivalent to 1/2 under this equivalence relation. So it's going to be the set of all M over N in Q, where 1 times n is equal to 2 times m. Does that make sense? I took the definition of the relation, I made this 1/2 and then used the s and the t. So this is a 1 and this is a 2. So 1 times t is equal to 2 times s. Are we good? Okay, so what are things that would make that true?
N is 2 and N is 1.
Yeah, which is 1/2, right? That's good. It should be equivalent to itself. This is an equivalence relation. What else would make that true?
Everything that reduces to 1/2.
It sure is. So 2/4, 3/6, 4/8, and so on. Yeah, all of the fractions that would reduce to a half. Positive and negative, right? Cool. Good? We need 2. So give me another, your favorite. What about just 2? Let's go with 3. Yeah, it is 3/1. So 3 times 3/1. So 3 times n would be equal to 1 times m. Oh.
There. There you go. I had that. 18/6.
Oh man, we can't do all the things that would reduce to 3. 18/6, 6/2, 30/10. I hate the order you did those in, Sherrod, but that's fine. Are we following that or not following that? All of the things that would reduce to be 3. Yeah. Okay. Okay. We're going to do scratch work only on this one. And then we'll do that proof. Oh, yes. We can hopefully finish this today. Oh my gosh. Holy, that's a lot of things. I'd like to get through page 15 today. I don't think we're going to make that, are we? No, ma'am. Okay, that's fine. All right, we have A, B, X, Y, and R2. That's R cross R. These are ordered pairs of real numbers. We're going to find A. B is related to X, Y. Oof, you know, let's use an R again. It's related to X, Y. If and only if A minus X is an integer. We are only doing scratch work. Scratch work. So for reflexivity, the reflexive property, what do we assume?
It's related to itself. The beginning.
That's what we have to show.
We assume it.
Yeah, we're going to assume AB is in R2, right? And we want to know, we want to show that AB is related to AB. And what that means is that A minus A is an integer. is it? I'm gonna let that happen. Let AB be in R2, and then I would say something like, notice A minus A is 0. Since 0 is in Z, A's AB AB is related to AB, and R is reflexive. What about for symmetry? What are we going to let be true? Okay. Assume what? What does the symmetry property say? That AB is related to XY. And what are we trying to show? No, what are we trying to show? Yeah, I mean, maybe, no, actually. What are we trying to show? Michael, you don't have to raise your hand, ever.
But I wanted to let her get.
Let her get it.
You got it.
That's gonna be a long time.
Well, I'm trying to translate what we did here to this problem.
What does it mean for something to be symmetric? A is related to B means what? It's symmetric.
Wait,
It's symmetric.
Make like the mirror image.
so XY is related to AB?
Yeah.
Oh, see,
See, we were all going to let you get there. My back hurts so bad. I'll try to stretch it out. It's crazy. Okay. XY is related to AB. Janiyah, what do we know since AB is related to XY? What do we know? Oh, actually, pause. What does that mean we're trying to show here? So basically,
that, A minus X is
you're answering my first question. Answer my second one now. What would this mean?
I don't know.
Yes, you do.
Wait, I feel on the spot now.
Don't feel put on the spot. Look at this. Look at me. AB is related to XY if A minus X is in Z. Okay. So how would we know if XY is related to AB? So if I put these in, there you go. See, we just needed you to have a moment. Yes, X minus A is in Z. Okay, Janiyah, but now you know the answer to the other question. Sorry, we're going to just keep going on this train. AB is related to XY. What does that tell us? You answered it correctly just a second ago.
B minus Y is
Well, not that answer. What does this say?
Oh, the A minus X is in Z.
Yeah, that A minus X is K for some K and Z. What would that mean about X minus A? You're not on the spot anymore, Janiyah. You can chill. I mean, you're welcome to answer also. It is negative K. What?
I was asking to ask.
Ask the question again. What do we know that? Thank you. What follows from this statement that would be helpful for us? that x minus a is negative k, yeah. Are we doing okay or not doing okay? We are understanding? Yes or no? Hello? Michael is now. Good. Corey, how are you doing? Good. Emily, how about you? Okay. Eunice? Great. Sharad's fine. Okay. Here we go. Transitive property. We're going to let 3 ordered pairs be in here. A, B, ugh, X, Y, and what else? M, N. Yeah, I hate this. It's fine.
What about OP?
Don't you be using O's. That is a silly choice. I would call that a red choice. A red choice. Because it looks like a 0.
But zeros are ovals.
I don't think it translates into handwriting though.
Mm-mm. You ever try to do a password or like a coupon code that had zeros and O's in it? We don't know what they are.
It's a small unit.
That's so true. I would just assume she had the right one, whichever it was supposed to be. Okay, A, B, X, Y, M, N are all in R2. We would like to assume what about these things?
So A, B, R, X, Y. X, Y relates to M.
And what are we trying to show?
A, B relates to M.
And what does that actually mean?
A minus M. Is it?
Cool. What do we know?
A minus X. Is X minus M. M. A minus X plus X minus M.
Nice work, Michael. All on your own. Nobody helped at all. I don't know if anybody was with us or not, but you did great.
I can do these. These ones are.
This is why these were my favorite proofs when I was in undergrad. Oh, yeah. There's a full page, but I can do all of it. It's fine. Just do these 3 things every time. Fine. Got it. Check. All right. Are we cool with number 4? Okay. I assume you could write a formal proof for it later. Eunice is like, sure could. Soon I'll be able to. Okay, these statements are equivalent. What time is it? 12:10. Okay. Did y'all know that equivalence under mod is an equivalence relation? Also shocking news. Breaking news. Okay. We'll prove it later. Let's do this proof for today, and then we shall be done. It's not that bad. Okay, R is an equivalence relation on a set A. If that's true, then these statements are equivalent, that A is related to B, that the equivalence class of A is equal to the equivalence class of B, and that their intersection is not empty. Okay, what this all means is that if two elements are related, their equivalence classes are the same. Their equivalence classes are either the same or do not overlap at all. So, because if the intersection is non-empty, then the things are the same, right? Yeah. So that would mean either they overlap all or none. They are disjoint or they are the same. Okay, so we're,
I'll just say,
okay, let's do this proof then. So proving that these three things are equivalent, we're gonna prove that like I or one implies two, that two implies three, and then that three implies one. And they've got a circle of like conditionals that would prove that these are all the same. Yeah? If I can prove that one implies two and two implies three and three implies one, then I've got, equivalence all around. So we are going to do that. We're going to let R be an equivalence relation. On a set, that's the word on, weird, on a set A. First, assume A is related to B. Okay, so how do we want to go about showing that it must be that the equivalence class of A is equal to the equivalence class of B? We will show, this makes sense. I'm with you. I'm with me now, and y'all will be too. We're going to show that the equivalence class of A is equal to the equivalence class of B. These are sets. So how do we do set proofs? How do we prove two sets are equal?
Single elements.
Yeah, so we're going to let X be in the equivalence class of A. Okay, we're going to show it's in the equivalence class of B. So then X is related to A, because if it's in the equivalence class of A, it's related to A. And we know A is related to B. By transitivity, X is related to B. Because it's an equivalence relation, so it is transitive. And then that means that X is in the equivalence class of B. So the equivalence class of A is a subset of the equivalence class of B. Yes? Yes? Okay, but these are sets. It's a subset proof. We're trying to show an equal to proof. So we got to do this the other way too. Good. Hiccups. The proof is the exact same, so I'm not gonna do it. I'm just gonna say it follows similarly. That the equivalence class of B is a subset of the equivalence class of A. Thus, the equivalence class of A is equal to the equivalence class of B. So now we're going to assume 2 and show 3. So we are gonna let A and B be in A. Oh no. I forgot to include where those were from on that one. Sorry about that. Oh no. This is just a disaster. Already talked about him. I hate myself for doing that to you. I'm so sorry. Okay, so since A is in A and R is reflexive, because it's an equivalence relation, A is related to itself. So A is an element in the equivalence class of A. But the equivalence class of A is equal to the equivalence class of B, so A is in the equivalence class of B. Thus, the equivalence class of A intersected with the equivalence class of B is not empty. And I don't have time to do the rest of this proof, so I will do it on Monday. I'm gonna see you again. You have that homework. I believe that you can do all of it. I would like for you to try it before class on Monday so you can ask me questions about it. It is due on Wednesday, either by email or dropping it off with Rachel. Good? Homework 12, that is. Okay, I'll see you guys on Monday. Have a good weekend. Goodbye. They're leaving, you're fine. What?
So basically, I'm learning how to write fast enough.
Yeah. I don't either. Corey, I have the notes in the office. Do you want them, or will you print them from Blackboard? Okay.
See you Monday.
Bye. You too.